Have you ever stopped to think about how you can stream a movie, check your email, and download a game all at the same time? It just works. But underneath all that seamless activity, there's this incredible, invisible world of architecture making it all happen. Today, we're going to pull back the curtain and demystify that hidden world that powers our digital lives. Okay, so let's jump right in with the big question. Think about what you're doing online right now. You're watching this, maybe your email is syncing in another tab, a software update is downloading in the background. How on earth does your computer handle all that traffic without getting its wires crossed? It's a fantastic question, and by the end of this, you'll see exactly how all those pieces fit together. So here's our game plan. We're going to take a tour of what I like to call a digital office building. First, we'll swing by the post office to see how data gets sorted. Then, we'll meet the different departments, all the services working behind your screen. We'll check in with the building management that keeps everything running, see how they all work together, and finally, we'll bring it all right back home to your own network. All right, first stop, the internet's post office. Just like every building has a street address, every single device on the internet, your phone, your laptop, your smart TV, has a unique IP address. It's how data finds its way from a server in California to your living room. But once that data arrives at the right building, it still needs to find the right office inside.
And that's where port numbers come in to save the day. If the IP address is the building's street address, the port number is the specific office number on the door. It's what tells your computer's operating system, hey, this chunk of data is for your web browser, and this other one over here is for your email. Without ports, all of our data would just get jumbled up in the lobby. Total chaos.
And this image here really brings that sorting process to life. See, the data arrives with both an IP address and that all-important port number. Your computer sees that number, like, say, 443 for a secure website, and it acts like a lightning-fast mailroom clerk, instantly shooting that packet of data over to the right application. This is what makes sure your video stream doesn't accidentally end up in your file transfer. Now, this whole system isn't just random. There are thousands and thousands of ports, but some of them are kind of like the executive floors in our building. They're reserved for very common services. Port 80, that's for your standard web traffic. 443 is for secure traffic. That's the little lock icon you see in your browser. And port 25 is dedicated to sending email. These are universal standards that basically keep the entire internet organized. Okay, so we found the right office, thanks to our port number. Now it's time to actually open the door and meet the departments that are doing all the hard work. These are the network services and servers. First up is the department you visit most often, the web server. You can think of this as the building's public-facing lobby and reception desk. When you type a website into your browser, you're really just sending a request to a web server. It then gathers up all the pieces of that page, the text, the images, the code, and sends it all right back to your computer to be displayed. Now, if we head deeper inside the building, we find the file server. This is the secure, centralized records room. For a business, this is the shared network drive where teams can all work on the same documents and projects. It's so important because it provides a single source of truth, making sure everyone is working from the latest version of a file. And way back in the back office, we have the real powerhouse, the database server. This is the building's massive, meticulously organized filing department. Now, you don't usually go here directly. Instead, other applications, like that website in the lobby, come here to request information. Things like your user profile, a product's price, or the comments on a post. It stores, manages, and retrieves all that critical data that makes modern apps tick. So this raises a good question. Does a company build its own records room, or does it rent space in a massive, secure warehouse somewhere else? Well, that's the key difference between an on-premise file server and cloud storage. Owning your own server means a bigger setup cost up front, but you get faster access for people inside the building. Using the cloud, on the other hand, is way easier to get started with. And you can access it from anywhere, but it usually comes with a monthly fee, and its speed depends on your internet connection. It's that classic trade-off between cost, control, and convenience. All right, so any large building needs a management team working behind the scenes, right? They handle security, utilities, logistics, all the stuff you don't see but can't live without. Well, in our digital building, it's no different. Let's meet the network's invisible helpers who keep everything humming along. You know that feeling when you connect to a new Wi-Fi network and it just works? Yeah, you can thank the DHCP server for that. Think of it as the building's friendly front desk. When your device shows up for the first time, the DHCP server says, "Welcome. Here's a temporary IP address for you to use while you're here." It makes connecting to a network absolutely seamless, saving us all from the nightmare of manual configuration. Now, in a more corporate setting, like an office or a school, you're going to find a head of security. In the network world, this is the domain controller. When you type in your username and password, it's the domain controller that checks your credentials. But more than that, it also manages your access rights. It basically tells the rest of the network which doors you have the keys to, which files you can open, which printers you're allowed to use. Next up is another kind of helper, the proxy server. A proxy is an intermediary that sits between all the computers in a network and the wider internet. It's like a concierge that handles all the outgoing and incoming requests, and it has two very, very clever tricks up its sleeve. So here's how it works. The very first time someone in the building visits a new website, their request goes to the proxy. The proxy then goes out to the internet, grabs the page, delivers it back to the user, and then it quietly saves a copy for itself. And this is where the magic happens. The next time anyone in the building wants that exact same page, the proxy doesn't have to go all the way back out to the internet. It just says, oh yeah, I've got that right here, and serves the saved copy instantly. The result is a much, much faster browsing experience for everyone, and it uses way less data on the main internet connection. Pretty smart, right? So when you put it all together, all these departments and management services, the records room, the head of security, the concierge, they all exist to help us do one thing really, really well: share resources. In our digital office building, this collaboration means not every single person needs their own private copy of every file or their own printer sitting on their desk. But sharing effectively requires some careful planning. I mean, you can't just leave the records room door unlocked, right? There are three critical things to think about: security. How do you keep unauthorized people out? Permissions. Who gets to just view a file versus who can actually edit or delete it? And finally, backup and recovery. What's the plan if data gets lost? A solid strategy here is absolutely essential. So we've just toured this massive, conceptual digital office building. But here's the really amazing part. A miniature version of this exact same architecture is humming away in your living room right now. Let's put all these pieces together. Just look at a simple home network. Your little Wi-Fi router is actually a multi-talented superstar. It's a DHCP server, acting as the front desk, handing out IP addresses to your phone, your laptop, and your TV. It's a switch, directing traffic between all those devices. And your laptop, it's using all those port numbers, our office numbers, to juggle web browsing, video calls, and software updates all at the same time. It's the exact same structure, just scaled down for your home. This whole digital building architecture is everywhere. And as we connect more and more of our world, our homes, our cars, our critical infrastructure, each one of those becomes another building in this vast, sprawling digital city. And that leaves us with a really big question for the future. How are we going to manage and secure all of these new digital buildings? Thanks for tuning in.